Well, good afternoon. Thank you for this opportunity. Talk was supposed to be given by Ilkay Altentas, who's the lead on this, what I think is an amazing project, the National Data Platform. And so I'm going to try to communicate what NDP is as best as I can. And we have a whole NDP team right up front there. And so if there are any hard questions, I'm going to punt them there. So I'll give you some context and then I'll try to, at a high level, describe what NDP is. So I think this is sort of redundant here, right? But it's just making the point that compute and data is becoming important, especially data, right? Here are two examples. The top one you might recognize.
Give it a couple more minutes. There's a whole bunch of people walking in right now.
All right, I can do it over.
Yeah. Sorry. Give it a couple more minutes. Okay, off we go.
Okay, so I can start over. All I said was good afternoon, and I'm representing Ilkay to talk to you about NDP, and that the hard questions should go to the first row. This slide sort of highlights the fact that computing and data are becoming, or cyber infrastructure more broadly, are very important for science moving forward. I picked a few examples here. The top one you might recognize, it's from UCSD. This is some work that was done by Romy Amaro on understanding how the COVID-2 virus propagates when one sneezes. And again, bringing together multiple data sets, computational platforms to enable this study was quite incredible. This is a picture taken from the New York Times, and of course the other one here is the second imaging of the event horizon of a black hole, and again, tremendous amount of data computing coming together. And then again, there are applications that need data and compute which are more urgent, such as understanding and responding to wildfires that we are learning a lot about, but other natural disasters where tremendous amount of data has to come together in a timely manner to support decision making. And to the more traditional mix of computing and data, we can add AI, which just further amplifies, accelerates, highlights the point that computing and data is critical. And as AI becomes an increasingly important part of everything we do, having the infrastructure that provides that data and that compute is tremendous. And the other point I'd like to make is the importance of making sure that not only, and that is sort of critical to projects such as NRP and others, that it's not only important to have the infrastructure, it is also important to make sure everybody has access and can benefit from and use that infrastructure. Democratizing that infrastructure is extremely important, right? With the study about how many studies have shown that the quality of research, the productivity, the impact of research is amplified, accelerated when you put in a diversity of thoughts, of perspectives in there, right? If you make it accessible to others, and that's specifically true for AI, where the nature of AI depends on who's developing it, where the data is coming from, who's using it. AI evolves, and so that makes it even more important that we democratize it. And there are a few dimensions here around democratizing. There is the technical aspect, which includes the infrastructure, the algorithms, the research that's being done. There's the policy and regulation around it that provides the guardrails within which the research and the development is done, and of course the training and workforce, which makes sure that we have the individuals that are trained around understanding how to use what and benefit. And there remain many barriers to actually democratizing this, including awareness about the technology, the data, the where it is, why it is important. Once you have awareness, the ability, right? The knowledge, ability to actually use it or to contribute to it, the ability to access it once you know how to use it, and then being part of a community, right? So there are a bunch of barriers come in, and there are a lot of efforts that are trying to address how do we reduce this. I'm going through this quickly just to set the stage. One such effort was the National AI Research Resource. Some of you might have heard of it. There was a report that came out in January of 2023. There's a tremendous effort right now by NSF in coordination with multiple agencies to move this forward as a pilot to demonstrate value and feasibility. And I know STSC and other such institutions are very big part of this in making sure that this moves forward. The goal was recognizing that infrastructure is going to play a huge role in AI. It is playing a huge role in AI. And the fact that only certain large, well-resourced institutions have access to this infrastructure has become an issue, right? It impacts the models that are being built, what type of models, what they target, how they're evolving, issues around fairness, bias. The whole bunch of issues are coming in because of this lack of access. And so what NAIR was trying to do was to see how can we create a national infrastructure that can democratize access to resources necessary to AI. And again, resources include computing, networking, expertise, and data. And one project to really address the democratization of the data dimension of this infrastructure is NDP, right? The National Data Platform. This is a pilot effort that's being led by Ilkay Altantas. It's a collaboration by a number of universities. I'm at the University of Utah, and I'm helping with that part of it. But we also have University of Boulder and the EarthScope project that's part of the collaboration. At a high level, what it's trying to do is recognizing that there's a lot of data out there, there's a lot of infrastructure out there. What are the core services that are needed that can make that data and infrastructure more usable, more democratized from an end user's perspective, right? What is the services that you can do that you can enable users to better make use of that data, whether it's being able to access it, integrate it in their workflow, run it on the resources that already exist, right? So at a high level, the idea is to build a platform for data-enabled AI-integrated workflows. It allows you to find the data, allows you to then access that data, integrate, make it right, and then integrate it into your workflow. The goal was to pilot this infrastructure and demonstrate it with a few representative applications, and I'll talk a little bit about those. And clearly, since the idea here is to value add on top of large investment that are already being made by NSF and other agencies such as NRP, but many other such investments, right? So the idea here is to partner and add value on top of these, not try to replicate what has already been done. At the high level, conceptually, it's made up of two pieces. One is a portal, a centralized portal, which is an entry point where a user can come in and discover both the data and the services that NDP provides, establish collaborative workspaces, and support education. The education hub that was in a tutorial yesterday, I believe, was part of this project. It can access to the hub. And the other part is more of a distributed, scalable infrastructure. And given this community, we regret the use of the name POP, point of presence, but think of it as a data POP, right? So it's not confusing. But the idea is to have very lightweight service stacks that can be located close to a data source or close to a community that can host services that add value to that data for that community, right? It's an ability for a data source to host services that makes the data look right from a user's perspective, right? There could be multiple user communities using the same data set, right? And they might want it to be accessed in a certain way, in a certain format, in a certain protocol, right? How do you make that data right for that community? So it's a very simple software stack, services stack that can be deployed there and that can be used. On the user side, a user community may be using multiple data sets in some way, and if we can share common set of tools and services that makes that data set more accessible, then how do you deploy that, right? So and this can be, you can have a large number of these NDP data points of presence that can be distributed in a decentralized manner. So like a hub and a spoke model is underlying this. If you dig in a little one step deeper, you see that you have a bunch of data sources, and these could be coming in from the major facilities that NSF funds or from other data repositories, other sources, and you have external services, right? NDP, again, made up of the NDP hub, where you have the core services, a portal, some search and discovery services, the education hub, and then you can have very customizable, lightweight points of presence, which then you can use to attach different data sets or communities to the NDP. We have some cross-cutting services, and I'll talk a little more about those as we go along. And then all of this builds on top of existing infrastructure, whether it's NSF funded, whether it is coming in from the cloud, right? It just builds on those capabilities. And NDP itself doesn't run its own resources other than the core services that it runs, right? The model it is bring your own resources. And that's sort of the model we built it on. This again goes into a little more detail of what's in the hub. And this is, some of these are still being developed. Remember, we are in year 2 of a pilot, so this is evolving very, very quickly. But there are substantial, as you saw in the tutorial yesterday, there's a good set of software and services that are already out there, and it's evolving very, very quickly. Let me give you some examples here. One is a search and discovery capability, right? So what we do is we harness, ingest metadata from existing data sets. We are looking at the NAIR pilot data sets that are out there, but also other data sets. The metadata is ingested into the NDP catalog, and it can be then discovered through that. But we have other kinds of search mechanisms as well that allow you to do contextual searches or searches using spatial maps, for instance. I need to find data sets in this region, right? So you can look and find multiple data sets across multiple data sources through a single portal. And then we're extending this to look at other ways that you can find data. One project that we have just started is to be able to find data using, for example, research context. I'm interested in studying the impact of wildfires on respiratory illnesses, right? So what data set should I use, right? Can we go and take that searches around some corpus, for example, OpenAlex, and find publication, and with that you can find out what data sets have been used, who used them, and what did it result. And so that can allow you to find data sets that you're trying to use. So clearly what we're trying to do here is to come up with more accessible search mechanisms to find data sets across multiple sources that might be meaningful to the research questions that you're trying to answer. Another very exciting concept here is notion of a workspace, right? This is a space, a personalized space that you create where you can bring in data sets, bring in workflows, bring in points of presence, and use that as a way to create and work with your science workflows and integrate data sets and access data sets, run your analytics, bring in services, right? It's a common environment that you can use to work on the data. Again, this is evolving quickly. It embeds a more customized Jupyter notebook in there, where you can then use Jupyter notebooks to be able to access the workspaces. Again, this is evolving quickly. We have some base features right now, but we're adding new capabilities to make this more useful as we move forward. And this is what I was talking about, being able to bring in Jupyter notebooks that then allows you to use that as an interface into these multiple data sets that you're working with. On the other side of this is the data pops, where, as I mentioned, these are very lightweight service stacks that are customizable. It comes with some basic stacks. It's to be able to authenticate, to be able to access the hub's catalog, to be able to create local catalogs for temporary data sets, to be able to authenticate. There's some basic services that come in with a POP, but then you can create your own services in there, right? You can create services that are meaningful for your data set or your community. It runs on a containerized platform, Kubernetes, where you can deploy containers and then use them to be able to customize the experience. And I'll give you some example to show you what that means. But the idea is to be able to create custom stack that really customize your data experience, either for your community or for the data source that you're providing, right? And here are some examples that we are building. The Science Data Exchange Stack is something that the Utah team and the San Diego team have been working together on. There are a couple of services that I'll dig in a little deeper to show you what this means. One service that we have been creating is a data staging service. And the idea is to be able to create a staging area to load in data temporarily while you're trying to make it right. And this is done close to the source, right? So, for example, in Amazon, there's a data, and this is a real use case that we were working with NASA on, right? They use a lot of NOAA satellite data that comes in, and every 5 minutes there's a new image coming in from their GOES satellites. You want to do some detection on it, and rather than download all their data onto their HPC facility in Ames, they'd rather filter that data on the cloud and only download data that's meaningful when they find features, right? So what they can do is on the cloud launch a staging service, which then loads the data, runs some mechanisms there to be able to detect whether the data is interesting or not, and download the data there. It could be fusing data, it could be subsetting data close to the source, right? So it's a generic abstraction to be able to create the staging service and to run operations on the service while the data is in memory there, right? And so this is a good way to be able to work on data in situ rather than having to download the data, right? And so this has been very effective here. I think I have a picture that shows the GOES use case. Yeah, so that's the one that we've been working with NASA on, right? But this is the idea to be able to create this elastic staging area on the cloud, right? So that they only download data when it is meaningful to their workflows, and be able to do a lot of manipulation of data on the cloud to detect or to make it most useful once they download it to their on-prem site, right? So this is one of the service. And so as a user, you can, when you install a point of presence, you say, I want a staging service, and then you install it there. And then every time you make a query, you can get it staged on the resources you have, and then use that as a way to work on your data in situ. Another staging service that we've been working on is a streaming service, right? And this is a way to be able to work on streaming data, again, at source, right? So that you can create, for instance, filter the data streams that are interesting to you, create derived streams, create notification on streaming data. Again, this is at source, right? And then to give you an example out here, we have been working with EarthScope, where they work off the GPS streams, right? So from GNSS, they have about 1,500, 2,000 streams coming in. And the typical way of doing this is that you subscribe to all these streams and then work on it at source, right? So what we do here is that the streams coming in, again, go into Amazon, right? And that's where you can subscribe to them. So we run a streaming NDP data pop there with a streaming service, which intercepts those streams and using simple filters creates derived streams. And then the users can only subscribe to the derived streams, right? So I can look at 1,500 streams and look for interesting, there they're looking at displacements in the X, Y, and Z direction. Their use case is early earthquake warning. They're looking for meaningful displacements across those streams. And so you can filter those streams there and then create derived streams that are interesting to your community, so you don't have to download 1,500 streams at 1 hertz, which is a lot of data, right? So this is kind of things you can do using services like that. I'm going to skip this for the interest of time, but I wanted to talk a little bit about how this all sits on top of NRP, right? That's become our platform on which we build this, right? So while NRP really democratizes a lot of the resources underneath, this adds a layer on top where you can then democratize the data workflows on top of this resource, right? As I said, NDP itself doesn't have its own resources. It's built on. You can bring your allocations from CloudBank, you could bring your allocations from a cloud, but NRP provides a nice platform on which you can build this, right? So here's an example where there's an NDP widget that allows us to import data sets into within NRP and then use NRP's resources to be able to operate on those data sets, right? So that's just one example for doing this. I know I'm running out of time, so let me skip this and just move here and talk to you about, so I have 2 more slides of the initial use cases. Clearly we started with 3, but we are discovering so many use cases that this is growing very, very quickly. But our initial use cases were sort of representative of large data sets, streaming data from NSF facilities, and then graph data with Nourish. And I think I have a slide with Nourish that Amarnath gave me, so I'll talk a little bit about this, right? So, and here are the sort of at a high level what these workflows look like. And the idea, again, was to demonstrate feasibility and value of this model for a variety of different use cases. In terms of, for example, streaming data, we are looking to see how can we use seismic data and GPS data coming in from these large NSF facilities to be able to facilitate early earthquake warning kind of or tsunami warning kind of workflows. In terms of large data sets, we are working with the wildfire workflow that ILCA has been working on for some time that really uses some of these large data sets and data sources to be able to model and support the management of wildfires. And then the Nourish is around food sustainability and sees how you can leverage open knowledge networks to be able to support queries based on these networks. And this is focused again on food sustainability. Just to give you one example, and then I'll stop. This is a use case that we have been using for some of our demos. I talked a little bit when I was talking about the streaming service, right? So we can get streaming service from Earthscope or Sage, and then when you create this point of presence in front of that data, which then allows you to do interesting things, such as filter and create derived streams, but also push the streaming data. For example, in this case, we use the OSDF Pelican origins to be able to feed it into workflows that are running in OSG. In this specific demo, right, what we're doing is taking data from Earthscope, and whenever you detect certain displacement patterns, you then run a workflow and OSG which creates synthetic data using that data that you get, right? And the idea is that you don't have enough representative data coming in for these natural events, which can be rare. So if you really want to build a model, you want to create synthetic data that's meaningful that can be used to develop that model, and that's what that workflow does, right? And we can also do real-time analytics and observation of these streams using a Jupyter notebook, right? And so if I had more time, I would open up a Jupyter notebook and give you a demo of this workflow, but that's it. And the same thing we can do for Sage as well, which is a sensor as a software-defined sensor testbed that NSF has funded. This is the same thing on how the Nourish is using NDP as a way to work on the data to make it and create this open knowledge network, which can then be used by end users to be able to answer queries such as build me a map which shows me where the food deserts are and how far are they from infrastructure or from supermarkets, for example. Right. So those are type of queries one could do by being able to take data and analysis or some raw information and then run this pipeline within close to the data using resources provided by NRP. With that, let me stop and say thank you and answer any questions as you have, if we still have time.
Any questions?
Hey, Manish. So you mentioned you used the term POP, and you also mentioned getting the NDP as close to the data source as possible. I'm trying to get a picture here of what this looks like. So is NDP going to deploy like edge devices or instruments to get as close to the data as possible? Are you planning to leverage projects like Sage, where you essentially put software in Sage for NDP? I don't have like a
Yeah.
visual.
Right. I know there is a well-defined notion of a point of presence in the networking community, which is infrastructure right here. And so that's why the use of the word is confusing. I know when I explained this to Kevin, he immediately jumped on it and said, bad idea. But anyway, to answer your question, no, it's the idea is to let's take Sage, right? So this is a service stack, right? It can run on existing infrastructure and close to data more in terms of access, right, rather than physical proximity, although that may be the case. So we could be running these services on the Sage platform itself, or we could be running this on an infrastructure that's well connected to a Sage platform, right? And that's what I mean close to it. Okay. It doesn't, and it's not, it is a software stack. It doesn't have, it doesn't come with resources, right? So you define which resources you want to run it on.
Okay.
Right. For example, Earthscope is running it on, their data is on AWS, right? So they run it on AWS. Right. NASA is running it on AWS because it's interested in data that's hosted at AWS, right? So it depends.
I see. Okay.
Any other questions? Otherwise, I'll chime in here. So, when if I understood correctly, what you're trying to do is have a composable service stack that can be deployed anywhere, right? But the deploying anywhere has sort of its obvious software problems that you have to build on some kind of API to actually be able to deploy.
That's correct.
Where the rubber hits the road. Is it fair to say that you're ultimately, that this is possible because containers have become so overwhelmingly common, and therefore deploying in a container API kind of environment into anything that has a container API is basically your lingua franca?
Absolutely. We're building on top of a container, and more specifically, currently we're building on top of Kubernetes, right? And that's the base thing that we build on, right?
So then, and when I translate this to my own way of thinking about this, my own language in a way. So when I think about building the stack that you can deploy into, I'm trying to federate all resources.
Right.
And therefore I would imagine there to be some kind of glue layer between them. And if it happens to be between the Kubernetes cluster, I am stuck with using something. And you're basically giving up on gluing anything.
Yeah.
You're saying, let's not be as aspirational. Let's just be able to deploy into any Kubernetes anywhere in the world. Anybody operates K3, K8, and that's good enough.
Yeah.
Okay.
And again, the exact interface, whether the aspiration is that right now, we might start with services like an app store where you say you can use one of these, and then have a mechanism to add to that app store that can run as services on one of these points of presence, and then you go to the next one where you have dynamically deployable.
And so if I follow that train of thought,
Yeah.
then that also sort of kind of means that all of the HPC environments that we typically see, whether they're DOE, NSF, NASA, you name it, doesn't matter whom, traditionally none of them supported container developments. Only if they did support container developments, they did it like this here, and not in a very so the fact that the world is changing, and that even DOE NERSC 10, so for example, even DOE environments are starting to say, as part of the requirements for the vendor, you must be able to support containers in some fashion. That basically advances the cause for NDP in a funny way.
Right. It does, right? And again, the idea here is to focus on getting the data to and from rather than going inside one of these big systems. But I think, especially as we start looking at some of the urgent workflows, right? Without containers, it's very hard to do, right? So I think it's just a matter of time. But for now, we're focusing more at the edges of these large systems.
Yeah, sure.
Yeah.
Cool, thank you. Any other questions?
Oh.
We're good? Then, Robert, I think you're next.